Right, good morning and welcome. This is Mr. Simons. This lesson we'll be sketching a cubic function given the drawing of the first derivative or drawing of a parabola and answering related questions. So given f prime x equal ax squared plus bx plus c, where f of x is a cubic function. I gave us there parabola has a y-intercept at 3, x-intercept at 1, x-intercept at 3, and the axis of symmetry is at 2, and the line that cuts it into 2 equal halves. Right. Now to say determine the x-coordinates of the stationary point of f of x. Now if you remember from the cubic function, we normally find the first derivative, make it equal to 0, and then we factorize and solve for x. Every time we found the first derivative, we found the equation of a parabola. So in short, if I have a parabola, the x-intercept 1 and 3 are also the x-coordinates of my stationary points. So therefore x equal 1 or x equal 3, as given there on the graph. Second question, state whether each of the above stationary points is a local minimum or local maximum, meaning it's either concave up or concave down, right? So you look at the graph when x is less than 1, so there's 1. X less than 1, what is the parabola doing? The y values are increasing. So my first derivative there is greater than 0. F is increasing or positive. If we look between 1 and 3, that is below the x-axis. So there my y values are decreasing or negative. So f prime x is less than 0, meaning negative. So f is decreasing. And when x is greater than 3, f prime x greater than 0, so f is increasing. So in short, we need to memorize local maximum goes from increasing to decreasing. Local minimum goes from decreasing to increasing. So they're increasing to decreasing. For x equal to 1, that's a local maximum. X equal to 3, it's going from decreasing to increasing. That is a local minimum. So that's the highest value my graph will turn at, and that is the lowest y value my graph would turn at. Right, so hope you follow and understand. Determine the x-coordinates of the point of inflection. So in simple terms, my axis of symmetry of a parabola is also my point of inflection. So there I can just say 1 plus 3, which gives me 4, divided by 2 always, equal 2. So there's my point of inflection. Right? Sketch the cubic function. So we should remember x equal to 1 is the local maximum. So that should be the highest turning point. X equal to 3, local minimum. And my point of inflection was at 2. So the graph for local maximum will always be concave down. Local maximum would be concave up. And there we've plotted the cubic function. Right, so I hope it makes sense. Feel free to comment or share or write a comment on what you think I should do to make the lesson better. Right, now if you look at the second problem, now I've given you f prime x equal negative ax squared plus bx plus c, where f of x is a cubic function. So now we're doing a graph, a sad face, where the parabola is facing down. X-intercept at 2 and 4, y-intercept at negative 16, and axis of symmetry at 3. Then, determine the x-coordinates of the stationary point. So whenever x-coordinates of stationary point is also my x-values of the parabola. So 2 and 4 my parabola is also my x-coordinates of the stationary point. So there x equal 2 or x equal 4. Alright. We go to the next problem. State whether each of the above is a local minimum or local maximum. So when x is less than 2, meaning if I go to the left with my x values, the y value is decreasing. So when x less than 2, my first derivative less than 0, meaning it's negative, f is decreasing. If we look between 2 and 4, Graph is above the x-axis, so therefore my y values, they are positive, right? You follow? So therefore f of prime x greater than 0, f is increasing. And when x is greater than 4, meaning I go to the right, my y values are decreasing, meaning it's below the x-axis, it becomes negative, so therefore my first derivative less than 0, f is decreasing. So decreasing to increasing, local minimum, increasing to decreasing, local maximum. So when x equal to 2, local minimum, that's concave up, x equal to 4, local maximum, concave down. Determine the x-coordinates at the point of inflection. So by now you know, add my two x-intercepts, 2 plus 4, which gives me 6. I always divide by 2 because I have two values, one the middle of those two, which then gives me 3. Sketch the cubic function. So local minimum, concave up, local maximum, concave down. So 2 and 4, you can see they're concave up, concave down. My point of inflection, 3, is in between. So there we've sketched, right? Please like the video, share with somebody that needs the help. It would be highly appreciated. God bless. Bye.